Okay, good morning, everybody. Hope you guys are doing well. Hope you had a good weekend. So, today we're going to continue our discussion in chapter 1, section 6, with that notes packet. And so today we're going to talk about what an independent versus a dependent variable is and how to tell the difference. So let's get started. So the first thing under vocabulary, this is where we left off on Friday, is a quick definition of what an independent variable is. And the independent variable um, is the variable whose value does not depend on anything else within the problem. And so almost always the independent variable is going to be at the x variable in an equation. So you can write an x in right there. So if that's the case, then the dependent variable is going to be the y value. So the independent variable is the x, the independent variable is the x. The dependent variable is the y. And if you would think of an equation like, for instance, y equals 2x plus 1, the idea here in this equation is the y value that you see right here is completely dependent on what you put in for x. So if you would put a 0 in for x, for instance, the y value would be 1, and it's 1 because you put a 0 in. So the y depends on what you're putting in for the x value. So that's another way to think about it. So we're going to look at some word problems, but before we do that, we want to we're going to practice here a little bit about picking which one is the dependent and which one is the independent. So again, to me, it's easier to figure out which one is the dependent, but we'll take a look. Okay, so the first one says the amount of decorations displayed, and then the second one says the number of tickets sold at the dance. So looking at this, do you think the amount of decorations displayed is going to depend on the number of tickets sold? Or do you think the number of tickets sold will depend on how many decorations that are displayed? So thinking through this problem, how do they raise money for a dance? Well, they raise money through maybe different fundraising. Maybe you sell candy bars, you do a car wash, and they also have to sell tickets. So by selling tickets, that gives us the money to decorate. And so the dependent one is going to be the amount of decorations displayed. So this is the dependent one. And the amount of decorations displayed depends on the number of tickets that is going to be sold. So the number of tickets is the independent. So hopefully that made sense. Let's take a look at the next one. So we either have the water level of the river and we have the amount of rain. So which of those is the dependent and which is the independent? I'd say this one's probably a little easier than the last one. But so the amount of rain is going to be the independent one. And depending on how much rain we get, that will indicate the level of the river. So the amount of rain is the independent, and the water level of the river is the dependent. The water level of the river depends on how much rain we get. Okay, so now this is a little bit more involved than the last one. So this particular problem has 3 steps to it. So it says, name the ordered pair at point A and explain what it represents. So there's 2 parts to this. Let's do the easy part first. The easy part is to determine what the ordered pair is. Remember, when we write ordered pairs, it's always the x value followed by the y value. So you can see right here, there is point A. And so you have to be very careful though when you count this out, because if you try to just count it You would say, well, I just went to the right one and I went up one, so it's 1, 1. That's not the case in this one because the labels on the X and Y axis are different numbers. So you have to go by the actual numbers. So you can see starting at the origin at 0, 0, we move to the right 1. So the X value would indeed be 1. But then the Y value, we've got to go up to there, and that value is 5. So the ordered pair is 1, 5 for the first one. Now, once we find the ordered pair, we have to determine what that ordered pair means within the context of the problem. And it says, name the ordered pair at point A and explain what it represents. And explaining what it represents is actually very simple. And it just has to do with what the X and Y values represent within the context of the problem. So you can see the X value represents the number of dogs that are walked. And then the Y value represents the amount of money earned. So this ordered pair 1, 5 represents if I walk one dog, I will earn $5. So number 2 is very similar to number 1. They want to know, they name the ordered pair at point B and then explain what it represents. So point B is right up there. So as we go down and we see here's the X value, which is a 5. So we went down from the point, we can see. Now we're going to go over and the Y value is 25. So the ordered pair for this one would be 5, 25. And now it asks us to explain what that point represents. And it's going to be the same as the last one. All the ordered pairs represent the same thing. The X value represents the number of dogs walked, and the Y value represents the amount of money earned. So when you have an ordered pair of 5, 25, it means you walked 5 dogs and you earned $25. Now, the last one says identify the independent and dependent variables for the relation. So you can see I already labeled our graph X and Y. So that's just a matter of remembering which is which. Remember, the independent is going to be X. So the number of dogs walked, I'm going to get a different color here. Let's go with, let's say blue. The number of dogs walked is the independent variable. And then the amount you earn is the dependent, right? So how much you earn depends on how many dogs you walked. All right, so the last type of problems that we're going to take a look at are going to be these problems where they give you a graph and they ask you to kind of interpret what is happening in each graph. And so really the interpretation comes from looking at what the labels are on the X and Y axes. So for number 3, part A, it says we're driving to school. So that's what the title of the graph is. And you can see the bottom part is time and then the top is distance. And so what this represents is a time that you're spending in the car and then how far away you are from your home. So you can see at first in this graph, at the beginning of the graph, it's pretty steep, right? So that means you got onto the road and you're moving. And then you can see that road, it flattens out for a short period of time. So maybe you hit a red light. And so the time is going by, but your distance is not increasing away from your home. And then as we move on further, so we went up, then we kind of flattened out for a little bit, and now we're going back up again. So now you're going farther away from home, and then it flattens out again. So maybe you hit another light, and now it's going up again. So now you're back on the road and you're moving. So that's what that one would be. The next one is a graph of the value of a rare baseball card. And you can see this one's pretty straightforward that as time passes, so time's on the bottom, that is the independent variable, the value of the card is continuing to go up like that. So it's going to continue to rise. Now, these are very similar to the last ones we just did. This is a track team practice. So it says describe what is happening in each graph. So you can see, and I'm going to try to trace this as best I can. Um, at first, this is time going by, which is down here, and the distance that you've actually completed. So at first you start out team practice, you're running, right? Maybe you run a few laps, and then you have a break because you can see it flattens out. So time's going by, but the distance you've run is not increasing at all. So maybe you're taking a water break or something, or maybe the coach is talking to you. And then once again, we get started. Maybe you're doing some sprinting there, and then you back off a little bit and do some jogging after that because your distance is not increasing as quickly. Now, part D represents the temperature in a classroom on a winter day. So, many of you probably have forced air in your house. I know I do. It's called forced air because what happens is your temperature, the furnace kicks on, your temperature goes up. And then over time, your house loses heat. So that heat starts going down. There's a certain point where your furnace says, "Uh-oh, it's getting too cold in here. I've got to kick back on and heat the house back up." So then it goes back up. And then it reaches the top. Okay, it's hot enough and the furnace stops. And then what happens? As soon as the furnace stops, temperature starts losing, going down because your house loses heat. And then it reaches a low point, and then the furnace kicks back on, temperature goes back up. And then this just continues. It goes over and over and over and over again. So your temperature in your house is going to look like this over time. And so that's exactly what happened. Now, this particular part right here at the end of the graph, if it went up like this and then down, there's a couple things that could have happened. You either shut your furnace off or it broke. Because the temperature, you can see there's a minimum amount right here across the bottom, right above that blue line, that the furnace is supposed to kick on. And if it goes below that, then that means either the furnace got shut off, or you lost power, or your furnace broke. Now it says which graph represents the height of a football after it's kicked downfield, and which graph represents the height of a baseball after it is hit. So we're going to have to assume when they say kick a football that they are kicking it on like a kickoff. It's not a punt, it would be a kickoff. So which of those is the accurate graph? Because you can see they both represent time and height. The difference is going to be right here at the very beginning. You can see right here, this one's starting at some distance off of the ground, whereas this one is starting directly on the ground. So my little hint where I said we're going to assume that it's a kickoff, that's going to be your hint. This one over here is going to be football, and then this one is going to be our baseball. Because a baseball is going to be some distance off the ground when it's hit with a bat, whereas a football, when it's kicked on a kickoff, is sitting on the ground on the tee. Okay, so this is going to be the last question we're going to try. Then we'll do an essential question, and then we'll be all done. So this one says, in a triathlon, athletes swim 2.4 miles, bicycle 112 miles, and run 26.2 miles. Their total time includes transition time from one activity to the next. Which graph best represents a participant in a triathlon? And so what you would want to think about, you can see all of these graphs are time over and distance. Whoops, that didn't mean to do that. Time and distance, right? So these are all time and distance. Now, what we have to determine, though, is which one would be the fastest. So if we look at right here, we have you swim 2.4 miles, then you bicycle, and then run. Okay, swim, bicycle, and run. So of those three, I'm going to order these from the slowest to the fastest. And so swimming, it will be the slowest. So that is going to be the slowest. The next faster one would actually be running. And then the quickest one is going to be bicycling. So one, two, three. Swim, bicycle, and run. Now, why did I order these? The reason why I ordered these is so we can understand what's happening in our graph. When you look at a graph that is distance over time, the faster the graph is going up, the faster you're going. The more or the less steep a graph is going up, the less fast you're going. So you're covering less distance. So what does that mean? Looking at these graphs then, if we swam first, the graph should be the least steep at the beginning. And then when we bicycle, it should be the steepest. And then lastly, when we run, it should be in between, somewhere in between swimming and bicycling as far as how fast the graph is going up. So if you look at this first one is straight. No change in your distance over time. So that is definitely not going to be an accurate graph because you're not going to swim as fast as you're going to bicycle. Um, if we look at the second one, you can see there are three distinct areas. There's an area right here, there's an area right here, and there's an area right there. The third graph, there's only two distinct steepnesses to the graph. And so that's not going to work because we did three different things. So you can see A is out and C is out, and B has to be the correct answer. And if you look a little more closely at it, you'll see that it is. It is the steepest at the beginning, and then it gradually reduces in its steepness. The running goes down. Now, I would argue um, this is actually backwards from what it should be. If we're bicycling, or what we could say is they didn't do that in the correct order. What they did, if you look here at the beginning, this is the steepest part of the graph. So my guess is they bicycled there, and then this one's the next steepest. Okay, so that means they were probably running there, and then this one is the least steepest, so that's probably the swimming. But the main thing to see is there's three parts to that graph, and the other ones did not have that, so that's going to be our answer. Okay, so the last part is essential question. Explain the difference between independent and dependent variables. So hopefully you can do that in your head. Um, One thing to keep in mind, the independent variable we call the x, the dependent variable we call the y, and you can think about all the examples that we did in this video and how that would apply to that labels. So, all right, guys, hope you're doing well. Let me know if you have any questions. Have a good day.